.NET Core Runtime with Richard Lander.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And we have a few announcements. My latest book, .NET DevOps for Azure, is available, and you can get it now at bit.ly/.NET DevOps book. That's bit.ly/DOTNET DevOps book, and the ebook at bit.ly/.NET DevOps ebook. There's also a special offer for user group leaders or conference leaders or really anyone speaking at those events. If you're involved with an in-person event, I'd love to send 2 print copies of the book for you to give away. And so to request those, just go to bit.ly/.NET DevOps book for community, and I'd be happy to get those out for you. We're getting it distributed onto Amazon and other places, but you can get the preview edition of the book right now. And I'm also working on the .NET Core 3 edition to come out at the end of the year. So lots of work to do. Now, we have a really interesting topic for today and a great guest. Richard Lander is a principal program manager on the .NET Core team, and he's been at Microsoft for 19 years, 16 of which has been on the .NET team, starting in 2003 with the Whidbey release, which is .NET 2.0. And he works on making .NET Core work great in memory-limited Docker containers on ARM hardware like the Raspberry Pi, and enabling GPIO programming and IoT sensors. And he's part of the design team that defines new .NET runtime capabilities and features. He enjoys British rock and Doctor Who, and he grew up in Canada and New Zealand. Richard, welcome to the show. How are you, sir?
Good. Thank you for having me. This should be fun.
All right, so British rock, who would you turn us on to if we're surf band songs?
Well, yesterday I was actually wearing a Morrissey concert tee. But yeah, I like him. I like Depeche Mode at times. And I also like bands like Bell and Sebastian. So those are 3 to start with. Awesome.
Well, I appreciate you coming on the show. You're one of the movers and the shakers on pushing the .NET platform forward. And you've been at Microsoft a long time, but what's that journey been like I mean, I'm sure lots of people seen you at conferences and online videos and blog posts, but for those not so familiar, how'd you get in this position? What's your journey been?
My origin story, kind of.
Yeah.
So I was going to university in Canada, and then I really got into document markup languages. So that was SGML first, and then XML, and that was really good experience. And then Microsoft said like, oh, well, we need some XML people. So I sent in my resume. They contacted me, and eventually I got hired. I'm obviously skipping lots of steps,
right?
And I did that for about 3 years. That's the difference between 19 and 16. And after I did that for a while, I kind of decided I wanted to do a new thing. And I also wasn't like super happy with the team I was on for a variety of reasons. And I thought, I'm kind of on like a C team, and I really want to be on an A team. And so I'll just skip the B teams entirely. So this is kind of how I was thinking about it at the time. And so I thought, CLR team, because that's what it was called in those days, Common Language Runtime. That's clearly the best team in the whole company. So let's throw my hat in there. My only major concern with that is I thought I had basically no specific skills to offer for that job. And I thought, everyone on that team must have a PhD. They're clearly must all be rocket scientists, and I fail on both of those qualifications. So it didn't turn out to be quite that bad. The hiring manager was actually incredibly nice, and we just talked it through, and he hired me. So that's the short version. I've always been interested in technology. My brother and I ran a bulletin board system while we were in high school.
Oh, nice.
So I knew what WinSock was, back in the early 90s, and did the whole modem thing. So I'm not and my first operating system was Microsoft DOS 2.0.
Oh, that's one of the early ones. Yeah, the times when you had to install your own networking stack.
Yeah. The other funny thing that's somewhat relevant is we had this DOS 2.0 disk. It was a 5 1/4 disk. And then we eventually bought an upgrade to DOS 5.0. And then we eventually bought an upgrade for Windows 3.1. And maybe we bought an upgrade disk for Windows 95 too. And so whenever we would
reinstall?
Whenever we would turf the whole machine, we'd have to go through this whole process of these upgrade disks, which was insane.
Yeah.
And probably not a good idea. But we didn't have, my brother and I didn't have huge amounts of money. So that's what we did.
Oh, you didn't just have the ISO images you download real quick?
No. Although actually, truth be told, we actually did run a pirate bulletin board. So we actually had quite a lot of Microsoft software on there. I think we had, Windows 3.1 in 10 disks or something like that. So,
well, in the days of really hard licensing, a lot of times you bought the product, and so you'd paid for it and you have it, but because of the medium or something, you almost had to get just a pirated copy just to be able to use it properly and for convenience. And so it's well, you paid for it. So that was pretty common because licensing just wasn't implemented that well.
Yes, it wasn't. So,
well, with so much going on now, and you're all over the place, writing blog posts and videos and speaking at conferences, there's a lot going on with .NET right now. What are the high points that you're spending most of your time thinking about these days?
Well, I guess there's really two things. One is we're still actively closing down the 3.0 release. And so usually at the end, what happens is some significant issue comes up, and then we kind of investigate it to its logical conclusion. And then we either decide, this one really needs to get squeezed into the current release, not necessarily in its best form, to compress it down a bit. Or we say, no, this one doesn't fit. Let's push it to the next release. And so this is one of, I have lots of design methodologies, for lack of a better term. So one of the things I do is, even if we're really late in the game, I say, okay, well, let's write down a spec that is the best version of this plan, even if everyone's confident it will not fit. And that usually gives us a really good objective description for making decisions. And where we have one of those going on right now, it's to do with the way that we added this roll forward across major version capabilities in .NET Core 3.0. But we didn't really do a good job of connecting it with .NET Core tools. And so, we're figuring out how we want that to work and how much of it is going to probably just slip into the next release. So that's an example.
Okay. We've been told that for the future of .NET 5, and I think are we really skipping 4? .NET Core 4?
Yeah, we're definitely skipping 4. So there's definitely some discussion still ongoing about the new name. 4 is definitely not one of the possible choices. We are absolutely skipping
because
that.
of the .NET framework. That 4.7 and 4.8 are kind of
Yeah, it's too much. I'm not interested in having that experience, disambiguating for customers the different 4.x series. Not going to do it.
Right. Okay. So essentially, we got .NET Framework 4.8. Then we had the core branch, multiple versions of that now, and we're going from .NET 4.8 just to .NET 5, and it'll all be the core stack. So that's been announced. So with .NET Core 3 coming out, is this the time where people who are hanging out on .NET Framework should really be thinking about their migration time, or do they need to wait for any more pieces?
Yeah, so I get asked that question all the time. There's no new pieces coming per se. Like up until .NET Core 3, for example, we obviously were still doing major work to bring pieces over. So WPF and Windows Forms are the two big ones. This release, there is nothing of that kind of thing planned. So the migration experience that you'd have with 3 will be the same with 5. Mm-hmm. So there's no reason to wait. I guess the usual advice we give customers is if you have an app that's not really getting much love on your side, and you're otherwise happy with it, you might as well leave it on .NET Framework 4.8 forever. If that's an app that's in active development and is important to your business, that's probably the reason it's under active development, then that should absolutely be a candidate for moving. There's a lot of benefits that .NET Core brings with it. That's why we decided to build the product in the first place, and that's also why it's had a lot of adoption. So that's just as simple as it is.
Okay. So I think you've been involved with the .NET 5 vision. What types of things are you thinking about? What does that mean? And have you announced the vision for .NET 5 besides just, hey, it'll come back together?
I think we've announced the vision in its broad brushstrokes form. We are working on details now across a variety of things. So, like, for example, one of the things that was kind of in our early vision was moving to one target framework. So actually backing up a tiny bit. So there are a few aspects of the vision. One was that everyone's developer experience should be the same. So that'd be like SDK style projects. You can use the .NET tools. And it should use the same kind of facilities in Visual Studio. Because underneath the covers, there's like several variants of .NET support in Visual Studio. And it's not always obvious to users which one it is they're using. And so it's important that we get all the .NET style projects. So that would be obviously .NET Core, Xamarin, Unity, all those onto the same thing. And it means everyone gets the same new capabilities on the same day at the same quality level and all that good stuff. So that's one part of the vision. It just means that we can put more wood behind a single arrow and then help a larger set of customers. So that's all good.
Okay.
The next kind of part was right now we have the .NET Core target framework. We have the .NET Standard one. Xamarin is kind of based on the Mono one, which is based on the .NET Framework one. And so .NET Standard has been a good mechanism for code sharing, and we'll continue to support it forever. Open question on whether we create new .NET Standard versions, but that's somewhat, I think, a bit irrelevant right now. And the idea would be is for these actual app platforms like .NET Core, Xamarin, Unity, how do we compress those down into one target framework, and then figuring out how to manage the different operating systems that they support. So that's another aspect of effort that's going on. I actually asked the team to put together a document. Love design documents. This is actually hard, the thing I just said. So I asked them, tell me all the bad ideas that you've come up with that you've already rejected. Because sometimes that process helps us get to a solution. Just just wallowing in despair of not finding the good answer is not super useful. So let's document the things we've rejected, and sometimes there are clues strewn across there that we can exploit. So that's another piece of effort. Another one is we're looking at repo consolidation. So if you've watched super closely, you'll see that we started out with like 1.5 million repos, obviously somewhat exaggerating, in the .NET Core 1.x and 2.x timeframes. And more recently, we've consolidated down a fair bit, like ASP.NET, I think, has 1 repo now, or like 4, some small number like that, whereas they used to have like 30. And we're thinking about basically consolidating down to a really small number for the whole stack.
Now, for listeners who haven't really looked yet, all of this development is done out in the open on GitHub, but things have moved around a little bit. So which GitHub organizations are the active, real ones at this point?
Yeah, so we have multiple organizations. Most of the code is in the .NET organization, certainly for the .NET CLI, .NET Runtime, the core framework stack. That's all in the .NET org. ASP.NET is in the ASP.NET org. They are thinking about coming over to the .NET org. NuGet client is in the NuGet org. MS Build is in Microsoft.
Okay, so that's github.com/dotnet, github.com/ASP.NET,
yeah,
and then /NuGet, just for listeners wanting to look those up.
And /Microsoft.
Yeah, okay.
So, engineering infrastructure has been a major cost to us over the last few years, since even before we went open source in 2014. I didn't use the word tax. I just used the word cost. So meaning I'm not trying to editorialize it and pass judgment on it. It continues to be quite expensive for us, although we're now starting to reap the rewards of all of that effort. We're kind of now getting slightly off topic, but we made the journey to Azure DevOps this last year and this year.
This is right on topic.
Yeah, we actually did a blog post about that.
Where can listeners find that?
Well, we'll probably have to put it in the show notes, but it's on the .NET blog. We put it in, I think, June. Actually, a really excellent post. One of our principal engineers who worked a lot on our Azure DevOps story wrote the post, and we're actually hoping to do more of those style of posts, which basically describe, how do we do engineering on the .NET team independent of the product we're actually building. I think lots of folks find that like super interesting. Mm-hmm. We definitely operate at a scale well beyond what most teams do, but there's problems that, then we've gotten this feedback actually on that blog post. There's problems that we have that are reminiscent, not exactly, maybe exactly the same thing, but very reminiscent of what, teams back at home deal with. And so they can kind of see clues, and almost all or 99%, I have no idea, of our build system and all that stuff is open source. So
meaning that people could see the build scripts that you use by going to the right place?
Yeah. I mean, it's we're beyond just scripts. We have programs that we like, tools that we use in order to make our builds work.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So here's a good question. If you've migrated to Azure DevOps and you're using the latest, which would be the YAML file for the pipeline, does that mean that if someone hooked up their own Azure DevOps org and pointed it to the CLR's GitHub repository, that they would actually spin up the pipeline for the CLR from that YAML file and just build it for themselves in their org?
I guess so. I've never tried that, but I think in theory the answer is yes. There's nothing about that that's closed source.
Okay. Yeah, the trick is which items don't quite make it into the Git repository, or besides just variables, because sometimes some scripts end up in that Azure DevOps configuration.
Yeah, I mean we're well outside of my my domain at this point, but everything about the way we build our product should be in those repositories that's on GitHub. Okay. The only thing that comes to mind that is closed source related to building our product is signing. Right. So we sign with, obviously Microsoft secret proprietary certificates, which anyone who knows anything about that topic will fully appreciate and understand. Yeah. Obviously, that's the right model. Other than signing, I'm unaware of anything that is closed source. Okay.
Well, the common language runtime certainly is in your wheelhouse, and there's some kind of progress on that, going from what's in scope for .NET Core 3, but then what's in the works for .NET 5. What are the high points there?
Yeah, can I just say one more thing about the last topic, which is I want to send one super clear message, which is people may have varying views about how we think about the source code that we've released. So we definitely think of ourselves as the primary stewards. And I guess, there's this like benevolent dictator for life meme. We think of ourselves similarly to that. And I don't think of that as a pejorative term. It means what it means. But it's incredibly important to us that the source code that we've released is accessible to anyone who wants to use it. And there's several scenarios to that. One is obviously someone who just wants to read it to learn. Another one is obviously contributors who want to contribute and be able to feel confident about their change by being able to build and test it. Then the other one is enabling third parties to do their own projects. So, for example, Samsung came to us a few years ago and said, we've been watching what you've been doing with this whole .NET Core thing, and we actually want to make it one of our platforms that we use for Tizen. And we were super excited and cooperative with them in order to make that happen, and that did happen. And they didn't necessarily need to approach Microsoft, but obviously that helped various things. And also it was super early, so we didn't yet have a track record on the goodwill of Microsoft and open source and licensing and blah blah blah. I think now that's probably hopefully a little bit more clear, but those are kind of the three scenarios, and we're absolutely open to all of those. So it's open source in the truest sense. We chose the MIT license on purpose because it's the do whatever you want license. It's very very not restrictive, and so I just want people to know that our open source thing is definitely not a marketing experiment. It's the full deal of what open source is intended to mean, and we're open to all the use cases of use of that code that one could really imagine. So I just wanted to make that clear.
Yeah, and that's really awesome because early in my career there was a problem. It was an epidemic across the industry, and that was you have say apprentice level practitioners who were lucky to work underneath a master with the team member who was really taking them under their wing. But something in every craft, in every art, in every trade, we learn by studying the finished product or studying the work of others. And if you want to learn to be an author, to write a novel, you can't do it without reading a whole heck of a lot of novels. And same thing exactly. If you're studying the works of Shakespeare in order to figure out plays or poems and all that. And so before the age of open source, just really difficult to be able to truly study the work of others. And so this shift just really enables the industry and enables people coming into it to learn at an accelerated pace just because of the bodies of work that are out there.
Yeah, very, very few of us are anywhere close to brilliant enough to, come up with amazing ideas in a vacuum, in a silo. So yeah, we totally need those things. They're just these well under 1% of the population that can really just do this on their own.
Yeah, if any. And then that's just pretending that we did it on our own.
Yeah, exactly. Yeah, well, I'm definitely not one of those people, let me tell you.
We all learn from others.
Yeah, I am so lucky. Like right now with, we finally moved to team rooms late last year. And I got super lucky with the folks that I'm sitting with. I sit with the leaders of the C# team and the leaders of the Runtime team. Mm-hmm. So anytime I have a question, it's like, ask these like oracles of knowledge my question. It's quite an enviable situation to be in.
Nice. Well, so mentioning the CLR team, what are the high points that people should pay attention to in the .NET Core 3 timeframe and then beyond?
Yeah, so I think the feature in .NET Core 3 that I worked on that I'm the most excited about is I've been working with Docker containers for several years now, and I've been kind of one of the people on the team that's been leading the charge on that effort. Initially, it was just focused on producing the actual container images and making sure that like our tagging scheme was intuitive enough that people could just grok what we were trying to do there, which we didn't do at first. And then more recently, we've been looking at Docker container limits. So this is memory limits and CPU limits, and there's some other things, but we'll stick to those two. And we did an initial implementation in .NET Core 2.1. It turned out that was too naive of an implementation, and people told us that. So I wrote up a spec that said, like, here's the general model that we want for .NET Core 3.0. And that was actually just focused on memory limits. Then the dev team implemented that, and then they actually implemented the CPU limits in an awesome way. And so I think .NET Core 3.0 is going to be much, much better at working in containers that are limited. So what this means for people that don't know about that is there's these subsystems in both Windows and Linux that people rarely use for governing what the resources that a process has available to it. And I suspect they're somewhat hard to use. Docker kind of like pulls all those things together puts a bow on top of it and says, like on the Docker command line, you can just specify, this process should only have 40 megabytes of memory at its peak or kill the thing. It should have a quarter of a CPU or one CPU or 6 CPUs, whatever is the right choice. And then it doesn't allow that process to see more of those CPUs. You can also affinitize the CPUs and say, and by default, you get the equivalent of 6 CPUs. They could be 6 random CPUs. I don't know how this is actually implemented. It's possible even maybe that you can switch CPUs across the process lifetime. That may not be the case. Mm-hmm. People in the comments will say he was dead wrong on that one. But with affinitizing, it would be the idea that you would pick a specific set of cores. And absolutely those, say, six cores would be those ones, and they absolutely would not move. So we have support for all of those scenarios now.
Okay. Now, you're mentioning Docker, and the question always comes up, okay, we're Docker for Linux came up first, but then we've got the different flavors of running those Docker images, and we're talking about CPUs. So we can run it as a Azure container instance. We could run it as Kubernetes. We could run it on a Linux Docker host. But then does that Docker support also translate to running it on Windows containers? Which pathways are real at the moment, and which ones are the easiest to get started for folks just getting into Docker?
Sure. So, I guess they're all real. So Azure, there's a few different aspects you are getting at. So Azure, for example, has several container-based services. The original one, I think, was Azure Container Services, ACS, and Service Fabric. And then now we have Azure Kubernetes Service, AKS. There's Azure Container Instance, ACI. And then also you can host containers with App Service, like Azure Websites or whatever that's called. So I think I'm not the Azure spokesman on containers, and I don't work actually super closely with those teams. But my guess is that the first, if you were going to go adopt an Azure service for containers, and the other one you mentioned, which is you can just spin up your own VMs and run containers. Obviously, that's not a managed container service at that point. But if you were to go do this, walk up to Azure and say, I want to host containers, I'm sure the Azure team would tell you to either start with Azure AKS, Azure Kubernetes Service, or App Service. And those are like two completely different ends of the spectrum. So, and then ACI, it's, a fully supported container service, but it really has a bit more narrow of a use case because it's only for hosting one container at a time. Obviously you can host multiple instances, but within a given service instance, you can only host one container and there's no orchestration. And I know that Azure Kubernetes Service, I believe, has a burst to ACI scenario. So that's one of the main use cases for ACI. And the other one, which is awesome, is if you just have a single container and you want to test it and get a public endpoint, public IP address for that, then ACI is perfect for that. And that's the main use case I use ACI for.
Okay.
And then really the app service hosting with containers is basically saying, I want more control over my dependencies than what app service normally has, say with Kudu. And then that's where containers make sense for app service. But there's no, to my knowledge, there's no orchestration. So if you have like 3 different services that are containerized, then I think you have to figure out how that all gets deployed and all that stuff. Whereas that care a lot about deployment coordination, then that's what puts you into the Kubernetes camp. Linux versus Windows. So I run Linux containers most of the time. I would say if we're using the easy metric, then Linux is easier to start with. Those images are smaller. Some aspects of them are simpler. So that's what I would at least start with to get your container feet wet. The only place where, and also the other thing is the Linux images have a much better backwards compatibility story. So for example, whatever version of Windows you're on or Mac OS or Linux, you can use whichever version of Linux containers that your heart desires. Whereas with Windows containers, there is like if you're still on like Windows Server 1607 or Windows 10 1607, meaning like quite some time ago, you can't use the new Windows container images on your machine. The guest and the host basically have to match.
Gotcha.
Which is not really an awesome characteristic, whereas Linux doesn't have that problem. So that's another reason why Linux is easier to start with.
Okay.
So,
well, that's a good rundown.
It is. There's a lot of depth there.
And I think there's also an ARM processor story. Is it being worked on, or is part of it ready?
Yeah. So one more point before we get to that topic, which is On Linux, we support 3 different distros with containers, meaning we actually produce container images for them, which are Debian, Ubuntu, and Alpine. So some of those words won't necessarily make sense to all the people at home. So Debian and Ubuntu are very similar to one another. Debian we consider to be the default image on Docker Hub. So that's the primary reason we support that. It's the default Linux image for .NET Core because of that. Ubuntu is just a really popular distro that we felt compelled to support. And Canonical is the company behind that, whereas Debian's a pure open source project that doesn't really have a company per se associated with it, as far as I know. And then Alpine is this kind of cool thing. It's a very, very small, stripped down Linux distro. It's like, I think less than 4 megabytes compressed.
Oh, nice.
Yeah, so very small. That's actually, even though Debian is the default, somewhat for historical reasons, Alpine is our preferred container platform. And the reason is because A, it's super small, and because of that, it probably has, or objectively has, a lower attack surface area. So those are the 2 main reasons why we like it.
It's like Linux Nano.
Yes, it's like Linux Nano, except way more nano. So then the next thing is chips. So we support 3 different chips. x64, obviously, because that's kind of the home chip of Docker, because Docker is mostly oriented around the cloud, and x64 is the cloud chip, as you know. But then we added ARM32 support for Linux in .NET Core 2.1 and for Windows in .NET Core 2.2. And in this .NET Core 3.0 release, we're working on ARM64 for Linux. And so those container images are already out there as well. So the Linux ARM64 isn't supported yet just because 3.0 hasn't shipped, but it is well on its way. And so the 2 ARM ones are more for the like Raspberry Pi /embedded /IoT space.
Mm-hmm.
That's what those are targeted at.
And you do quite a bit with the Raspberry Pi. Well, just tell us about that.
Yeah. So at first, it was just about supporting the ARM chip and that kind of thing. In the 3.0 project, we did an additional thing, which is if you've ever seen a Raspberry Pi, you'll see there's all these pins on it. I think there's 40 of them or some such number. And if you want to talk to a sensor or a small display or like a servo, then you actually have to program those pins. And so basically what you're doing is you're sending or receiving electrical signals, digital electrical signals across those pins to either communicate or just to drive an electrical device. And up until 3.0, we didn't have APIs for doing that. There were a bunch of community libraries for doing that were all of different shapes and sizes. And so we felt compelled to build our own. And so the reason behind that was maybe 3-part. One was a bunch of the managed libraries were built on top of native libraries. Mm. And so those native libraries didn't necessarily work on all the places our product works. So for example, they didn't necessarily support Alpine ARM64. So that's anytime that we have to pull native code to all the places, it's really hard unless it's native code that we actively maintain. So that was the first reason. The second reason was a bunch of it was GPL. So we try and avoid using GPL as much as possible. So I'm not a GPL hater or anything like that.
Just from a practical stance, if you embed it, now the license kind of ties your hands.
Yeah, I mean, so we like to have very simple conversations with our customers. MIT, Apache, BSD, they allow us to have very simple conversations. GPL would not, and we'd have to think through all the use cases. So there was no way we could build a Raspberry Pi IoT story on top of GPL library. So that was the second reason. And then the third reason, I guess, is similar to the first one, which is we wanted to have, like, the other problem was some of these libraries, like, say, for example, there's LED matrices. There's a native library just for that, and so it would be native code all the way down. But then imagine we had a managed GPIO library, so that LED matrice library wouldn't actually build on top of our GPIO library. So we wanted to have an all C# solution from top to bottom. It meant that, every scenario would kind of build on top of the basic building blocks. It also means that you wouldn't have to have a native tool set to contribute to the library. So because it's all C#, like, you can use SourceLink, for example, to, like, see all the code in the debugger. So the building our own library for C# made a ton of sense. And actually, there's one other reason, which is this is now getting into all the complexities of IoT and this stuff, but there's actually 3 different ways to talk to the pins on, say, like a Raspberry Pi. There's sysfs, which is basically all those pins are kind of exposed through the file system. So you can actually, like, type cat 0 and then pipe it to a particular file, and that, like, that would turn off the pin, or cat 1 pipe, and then it's like /sysfs/GPIO/6 or whatever to talk to pin 6. So you can actually use the file system. That's super slow. So we support that scenario, and there are cases where that is the best choice. And then there's a new thing called libgpiod. That is the new cool kids way of talking to all those pins. So we support that. And then also you can write board-specific drivers that basically kind of do everything in memory. So our C# library and C# abstraction enables all 3 of those scenarios. And I think there were very few libraries out there that supported all 3 with the same API. So those are all the reasons we built Runtime.
Okay.
So you can see some amount of thought went into them.
Yeah. And so these are all NuGet packages to add on, right?
One NuGet package.
One NuGet package. Now, any bindings specifically for Raspberry Pi, or is this across all things, including Azure Sphere and the other devices?
So good question. The answer is yes and no. So this is where all these different things come back into play. So sysfs and libgpiod should work on multiple devices. We have a Raspberry Pi specific driver, and I think we have a Hummingbird specific driver, but the more generic solution should work on pretty much any type of board. Now, we only support ARM-v7 and up. Okay. The ARM versioning scheme is even more crazy than the .NET Core one. So, for example, like Raspberry Pi 2 is ARM-v7, Raspberry Pi 3 is ARM-v8, Raspberry Pi 4 is ARM-v8, Raspberry Pi 0 is ARM-v6. So we don't support that. We're v7 and up.
Okay.
And then I don't even know what Azure Sphere is, but it's definitely lower than ARM-v6. So we don't support that either. It's both not a chip we can support, and the amount of RAM and storage space on the device is too small.
Yeah, last time I checked Azure Sphere, we had to use Visual C++, sort of the editor, really just to write regular C code. It doesn't even have the CLR, just as far as the documentation goes. I wonder, that'd be great to change at some point.
Well, I think what will happen, so this is just me guessing as opposed to me having spent any time with that team, but I suspect what will happen is, like, they started with a first product, which was targeted at a particular use case, which is this super small thing. And I have every reason to believe that was the right choice. But I suspect over time, they will build different classes of devices. Maybe they'll build something that is more similar to the Raspberry Pi and say uses an ARM-v8 chip. But but otherwise has all the Sphere-like security capabilities, then .NET Core could probably run on such a device. But they're not there yet, and we're not there yet. So
okay,
that's for a future conversation.
Can I throw out a scenario and you tell me which what blockers may be there in plans? So you got the Raspberry Pi, and of course the Raspberry Pi 4 just came out, and one of the models has 4 gigabytes of RAM, which is huge, and the specs, the performance specs seem to be pretty cool. And so for just the .NET developers wanting to get some software out in the field where it's not the factory type IoT or tons of sensors going on all the time, but they want to put some software out where it's hard to put a full-on computer. But hey, stick a little Raspberry Pi, deck of cards somewhere. What would stand in the way from the following architecture? Installing a Azure DevOps agent to be able to push updates, and then being able to push out small applications wrapped in a Docker container on that Raspberry Pi. Are the pieces in place where that's doable now, or what would be easier versus difficult?
So there's you could already do that thing with .NET Core 2.1, what you just described. I think the only thing that would be challenging, for lack of a better term, is you would have to build some kind of an orchestrator to basically, know that a new build is available, gracefully shut down the container that was running, and then, well, you probably wouldn't do it in this order, but pull down the new container images from whatever your registry was, and then boot that back up. So that would be the only thing to figure out. Now, I suspect that there are lots of devices that are doing exactly this thing. So this is not untrodden ground by any stretch of the imagination. And in fact, we're working with various companies, and they're doing something very similar to this. And this is kind of why container-based delivery is super attractive, because you literally have a single command to pull down a new version, Docker pull, and then you have a single command to launch the new version of your application, which is Docker run. So to me, that's incredibly compelling. And it's super easy to, especially on constrained devices, to scavenge old versions of the application. Docker image RM. So it's extremely compelling. But yeah, there's nothing stopping any of that. That should have already worked with .NET Core 2.1, where we first supported ARM32.
Okay, so with the GPIO libraries, it's just putting on whatever hats or sensors or cameras or whatnot. Just the general programming becomes a lot simpler and consistent.
Yeah. So as I said before, with .NET Core 2.1, we didn't expose a way to program these pins. So the pin, you only need to use the pins if you're talking to sensors and displays and that kind of thing. So the package for that will ship with .NET Core 3.0, but it's actually a .NET Standard package, so it will work on .NET Core 2.1 as well, and that was intentional. I'll mention one other thing with that is I said there's one package, but there's actually two.
Okay.
The first package, so I wasn't actually lying, but the first package is the one that has all the GPIO libraries in it. The second one is actually a higher level, and so that's system.device.gpio.
Mm-hmm.
The second one is called, I think it's called IoT.device.bindings, and these are both on NuGet.org. And so that one is a bit different. It's a set of higher level libraries that is a community supported set of libraries that basically says, there's this temperature sensor, BME 280. And to actually code against these GPIO APIs directly is a bit of a pain in the butt, and can be actually difficult. And so the community has kind of come forward and said, we're going to build a bunch of bindings. They provide a nice, pretty C# class for you to code against. And then it's super easy to talk to the BME 280 to find out the humidity and the temperature. And so that's what the second one is all about. So there's about 50 of those bindings right now. In the fullness of time, like in a year or so, I'd like to get it up to 100. In a few years, I'd like to get it up to 500 bindings.
Right.
And then this is one of the things I'm spending time thinking about, which is how do we? There's a world in which this set of bindings becomes a total Wild West, and no one can reason about the quality of any of them, and there's a ton of duplication and all these things. And obviously, that's a world that I'm trying to avoid. So this is something I'm going to be doing in the remainder of this year, is how do we start to better organize those bindings so they're easier to consume? How do we communicate a higher level of quality for certain of them? How do we let users kind of vote to say, like, these are the ones that I wish were higher quality? Lots of things like that. Another thing we're thinking about is there's one form of duplication, which is, there's like 6 badly written bindings, all for the BME 280. I'm just going to continue with that one for this. But there's another one, which is there's actually several different temperature sensors that you could buy that are fundamentally different, but there's relatively little value in them having distinct APIs. So we've also been thinking about, maybe we need to build an eye temperature interface, so that they all expose. Now it's possible that there's additional functionality that some of them might expose. So if you need that, then obviously you wouldn't use the eye temperature interface. But for the basic stuff, having a common surface area for all of them. So that's another thing we've been thinking about a bit.
Man, well, this is a lot of stuff, and all by being able to write C#. So C# is going in so many different places for so many different scenarios. It's pretty exciting.
Yeah.
We'll have to come back and maybe do a show about an IoT DevOps environment, what it looks like, what it looks like, soup to nuts to build and deploy, and all the different types of testing for that type of environment. That would be a interesting show.
I have a little kind of a joke for you on that one. It's actually not a joke, but so as I said, we use Azure DevOps to build our product in the same way, more or less, that everyone else does. And one of our problems is, like, as we say, brought up ARM64. Well, there isn't a Azure DevOps agent that runs on ARM64, because the Azure DevOps agent relies on .NET Core. They're using the last version of .NET Core. So we actually have to work with the Azure DevOps team to, like, build together this cobbled, like, total Frankenware Azure DevOps agent. And then eventually we kind of, like, get that working, then get the product to a state that the Azure DevOps team can adopt it. And then they can make it available to other people than just us. So there's always this dance that has to happen. Obviously, it's not visible to people outside, and the fact that it isn't is an indicator of success. But that's a funny thing.
Yeah. So the current Linux agent does have that x64 dependency, and it needs to be, and we need a version for ARM. Is that right?
Yeah, for ARM. ARM. But I think that that's all being fixed. But we're the first ones to always run into it because we're an Azure DevOps customer.
You're dog-fooding it.
Yeah, we are dog-fooding it.
Well, hey, this is a lot of great information. We really appreciate it. We'll make sure to include the things that we talked about in the show notes. But if someone wants to learn more about the different interesting places that the Common Language Runtime is going, is there any other go-to resource that you would point them to learn more?
I think I would just point them at our blog. Look for the .NET Core 3.0 preview blogs. Maybe by the time some people are listening to this, .NET Core will have already shipped. 3.0 would have already shipped. But I think that's the best place to learn. There's also our docs
Is that devblogs.microsoft.com/dotnet?
Yeah, that's the
Awesome.
one.
Cool. All right. Well, thanks so much, Richard, for being with me today. This is great.
No problem. Yeah, I love spreading the word.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.